Okay, dear students, welcome to mathematics online classes. In the exercise 9.2, only the last problem is remaining, that is problem number 18. Problem number 18 is that the difference between any two consecutive interior angles of a polygon is 5 degree. Polygon in the sense of ಬಹುಭುಜಾಕೃತಿ, ಕನ್ನಡದಲ್ಲಿ ಬಹುಭುಜಾಕೃತಿ ಅಂತ ಕರೀತಾರೆ. If the smallest angle is 120 degree, ಅದರಲ್ಲಿ ಸ್ಮಾಲೆಸ್ಟ್ ಆಂಗಲ್ 120 ಡಿಗ್ರಿ ಐತ್ರಿ. ಫೈಂಡ್ ದಿ ನಂಬರ್ ಆಫ್ ಸೈಡ್ಸ್ ಆಫ್ ದಿ ಪಾಲಿಗಾನ್, ಅಂದರೆ ಆ ಸೈಡ್ನಲ್ಲಿ ಮೀನ್ಸ್ ಆ ಬಹುಭುಜಾಕೃತಿಯಲ್ಲಿ ಇರತಕ್ಕಂಥ ಬಾಹುಗಳ ಸಂಖ್ಯೆ ಎಷ್ಟು ಅಂತ ಇಲ್ಲಿ ಕ್ವಶನ್. ಓಕೆ, ದಿ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಎನಿ ಟು ಕಾನ್ಸಿಕ್ಯೂಟಿವ್ ಇಂಟೀರಿಯರ್ಸ್, ಅಕ್ಕಪಕ್ಕದಲ್ಲಿರೋ ಯಾವ್ದಾದ್ರು ಎರಡು ಆ್ಯಂಗಲ್ಗಳ ಮಧ್ಯೆ ಇರತಕ್ಕಂತಹ ವ್ಯತ್ಯಾಸ ಎಷ್ಟೈತಿ ಅಂದರೆ ಅದು 5 ಡಿಗ್ರಿ. ಆ ವ್ಯತ್ಯಾಸ ಅಕ್ಕಪಕ್ಕದಲ್ಲಿರೋ ಎರಡು ಆ್ಯಂಗಲ್ಗಳು ಅಂತ ನೋಡಿದ ತಕ್ಷಣ ನಮಗೆ ಗೊತ್ತಾಗ್ತದೆ ಇದು ಅರ್ಥಮೆಟಿಕ್ ಪ್ರೋಗ್ರೆಷನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಪ್ರಾಬ್ಲಮ್ ಅಂತ. ಓಕೆ, ಹಿಯರ್ ಐ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಕಾಮನ್ ಡಿಫರೆನ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಕಾಮನ್ ಡಿಫರೆನ್ಸ್ D is equal to, that is nothing but a 5 degree. If the smallest angle means that will be first term of the arithmetic progression. Smallest angle I will consider that as A, that is given as a 120 degree. With this we should find out number of sides of the polygon. So here we will use one general term. What is that? A polygon having n sides, n number of sides, in which means in that sum of interior angles of a polygon, we should know the formula for that. A polygon having n sides will be having interior angle sum, will be having interior angle sum as Sn is equal to n minus 2 into 180 degree. You should know this. Polygon, if you consider the triangle here, triangle tribhuja, how many sides it will be having? It will be having 3 sides. N equal to 3, if we substitute the internal angle sum is 180 degree value. Similarly, if you go to the square or a rectangle, whatever, a 4-sided figure, if you substitute n is equal to 4 minus 2 into 180 degree, 360 degree, that is internal angle sum. Fine. Now we have Sn is equal to n minus 2 into 180 degree as the formula. But what is Sn here? Sn is sum of first n terms of arithmetic progression formula here. Okay, using Sn formula, having n sides over there, n by 2 into 2a plus n minus 1 into d, which is equal to n minus 2 into 180 degree. N by 2, you keep it as it is. N is the unknown quantity, we need to find out that. 2a, 2 into a means smallest angle, that is 120 degree, plus of n minus 1 into d, difference between consecutive interior angles, that is 5, which is equal to n minus 2 into 180. We need to simplify this. Here we see we left with only n here. Okay, simplifying this, let me take this n to the right hand side, this 2 to the right hand side. N, we have n into 2 into 120 degree is 240. 5 will get multiplied with these two. 5n minus 5 is equal to this 2 I am multiplying to the right hand side. N minus 2 into 180 into 2 is nothing but a 360 degree. We have here again we can simplify n into 5n plus 235. 240 minus 5 is 235. This is equal to n minus 2 into 360 degree. N will get multiplied with these two. 5n square plus 235n, which is equal to 360n minus of 360 into 2 is 720. Simplifying this, 5n square plus 235n minus 360n plus 720 is equal to 0. You can observe here all have a common factor of 5, means all are divisible by 5, so you take the 5 outside. If you take 5 outside, that is 5 into n square plus of 5 4s are 20, 3 will be there, so 5 7s are 35 n minus of 360, in the sense 5 7s are 35, 1 are 10, 5 2s are 10 into n plus of 5 1s are 2 will be there, 22, 4s are again 2 will be there, 20, in the sense 4 144, which is equal to 0. 5 will go to the right hand side and that becomes 0. N square 47 minus 72 is nothing but, you can check it, it is 25 plus of 144 is equal to 0. Now n square, it is a quadratic equation, solve it by factorization. Minus 16n minus 9n plus 144 is equal to 0, I can write. Minus 25 minus 16 or minus 9, it becomes minus 25 and its product become 144. N is common here, n into n minus 16, here you take minus 9 common, n minus 16 is equal to 0. N minus 16 is common, n minus 16 into n minus 9 is equal to 0. Now I have two answers, one is n minus 16 is equal to 0, another one is n minus 9 is equal to 0. N is equal to 16 is one possibility and a second possibility is n is equal to 9. But here you see, this n is equal to 16 is not possible. Why n is equal to 16 is not possible? Number of sides of a polygon is equal to 16 is not possible in this case, because just what you do in a rough work, you find out the nth term. An is equal to, means you find out the 16th term. A16 is a plus 15d. A means it is given 120 degree plus 15 into common difference is 5. 120 plus 15 into 5. 15 5s are 75. 120 plus 75. How much we are getting? We are getting 195. See, in a polygon, any one angle, interior angle can't be more than 180 degree. But here we are getting 195. So this n is equal to 16 is not possible. N is equal to 16 is not possible. Therefore, number of sides of polygon is 9. Only 9 is the possible answer. With this, we finish the second exercise of the of the sequences and series. Now we will go to the next concept, that is geometric progression. Now we are going to deal with geometric progression, that is GP. See, with an example I will explain you. I have a sequence here 2, 4, 8, 16, 32, so on like this. This sequence is called GP when it satisfies some condition. What is that condition? The ratio between any two consecutive terms should be same. Andre, ನೀವು ಯಾವ್ದಾದ್ರು ಎರಡು ಅಕ್ಕಪಕ್ಕದಲ್ಲಿರೋ ಟರ್ಮ್ಗಳದ ರೇಷಿಯೋವನ್ನು ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ, ಅನುಪಾತವನ್ನು ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಆ ಅನುಪಾತ ಸೇಮ್ ಆಗಿರಬೇಕು. ಅಂದ್ರೆ you take a2 by a1 here, means if you consider this as general sequence, it will be a1, it will be a2, a3, a4, a5, so on. a2 by a1 is how much here? a2 by a1 is 4 by 2, 2 ones are 2 2s are, answer we are getting 2. Next, you see a3 by a2, a3 by a2 is 8 by 4, 4 ones are 4 2s are, see we are getting 2. And you check a4 by a3, A4 is 16 by 8. 8 ones are 8 twos are, we are getting 2. Means ratio between any two consecutive terms is the same in the given sequence. So such type of sequences are called geometric progression. Okay. ಅಕ್ಕಪಕ್ಕದಲ್ಲಿರೋ ಯಾವ್ದಾದ್ರು ಎರಡು ಪದಗಳದ ರೇಷಿಯೋವನ್ನು ತಗೊಂಡ್ರಿ, ಅನುಪಾತವನ್ನು ತಗೊಂಡ್ರಿ, ಅದು ಹಿಂಗೆ ಈ ತರ ಸೇಮ್ ಬರ್ತಾ ಹೋಗ್ತು ಅಂದ್ರೆ ಆ ತರದ ಅನುಕ್ರಮವನ್ನು ನಾವೇನ್ ಕರಿತೀವಿ, ಜಾಮೆಟ್ರಿಕ್ ಪ್ರೋಗ್ರೆಷನ್, ಗುಣಾತ್ಮಕ ಶ್ರೇಣಿ ಅಂತ ಕರೀತೀವಿ. ಓಕೆ, ವಾಟ್ ಇಸ್ ದಿ ಡೆಫಿನೇಷನ್ ವಿಲ್ ರೈಟ್? ಆ ಸೀಕ್ವೆನ್ಸ್ A1, A2, A3 so on up to AN is called geometric progression, that is GP if ratio between any two consecutive terms is same, where ratio is called common ratio, So now I can write it in general like that. Suppose I have A1, A2, A3 so on up to AN is a GP. If it is a geometric progression, then we will be having common ratio R is equal to can be taken as A2 by A1, and this will be equal to A3 by A2, and also R is equal to A4 by A3, so on like this. In general, what I can write, R is equal to AN plus 1th term divided by ANth term, its previous term. This is one way of explaining. Let me tell you in another one case. See here, first term is 2, and our ratio is 2 here again. Ratio is also 2. How will you get the second term? Second term we will get by multiplying 2 to the first term. 2 into 2, 4 we are getting. Means they are multiplying the common ratio here. Now coming to the third term. How will you get the third term? Third term we will get by multiplying 2 to the previous term, that is second term. Third term ಅನ್ನು ತಗೊಳ್ಳಲಿಕ್ಕೆ ಎರಡನೇ term ಗೆ common ratio ಅನ್ನು multiply ಮಾಡ್ತೀವಿ. 4 into 2. Next ನೋಡ್ರಿ, fourth term 8 into 2 16. Fifth term 16 into 2. ಅಂದ್ರೆ previous term ಗೆ common ratio ಅನ್ನು multiply ಮಾಡೋದ್ರಿಂದ next term ಬರ್ತೈತ್ರಿ. So here what I can write? We can write here second term is common ratio into first term, and then third term is common ratio into second term, fourth term is common ratio into third term. In general we can write n plus 1th term is equal to common ratio into nth term. This one you should know. Means in geometric progression succeeding terms are obtained by multiplying common ratio to preceding terms. First term ಗೆ common ratio multiply ಮಾಡಿದ್ರೆ second term ಬರ್ತದ್ರಿ, second term ಗೆ common ratio multiply ಮಾಡಿದ್ರೆ third term ಬರ್ತದ್ರಿ, third term ಗೆ common ratio multiply ಮಾಡಿದ್ರೆ fourth term ಬರ್ತತಿ. This is what our geometric progression concept is. ಇದೆ ಇಷ್ಟೇ ನಮಗೆ geometric progression concept. Now we will write general geometric progression. as we discussed in arithmetic progression, that is general arithmetic progression, that is a plus d, a plus 2d, a plus 3d. In the same way, we will write the general geometric progression here. See, to write the general geometric progression, I will consider, let first term is equal to a, first term is equal to a, and common ratio is equal to r. Common ratio is equal to r. Now what will be the general geometric progression? Let me consider here, let a1, a2, a3, a4, so on up to an are in GP. You geometric progression let here first term what I have considered, first term equal to I have considered as a, so first term will be a, keep it as it is. Next second term, to get a2, what I told you second term is obtained by multiplying common ratio to the first term. Means first term, if you multiply with common ratio r, we will get the second term. Second term will be a into r. What about the third term? Third term is obtained by multiplying common ratio to the previous term, that is second term. So ar into r it is. Ar into r is ar square. What about the fourth term? Fourth term is obtained by multiplying common ratio to the third term, that is ar square into r. It will be written as ar cube. You see, a2 means a into r to the power of 2 minus 1 I can write. a3 means a into r to the power of 3 minus 1 I can write. See here, a into r to the power of 2 minus 1 I can write. Second term. Fourth term I can write a into r to the power of 4 minus 1. In the same way, what we can write for the nth term? For nth term we can write it as a into r to the power of n minus 1. Therefore, nth term of a GP is written as an is equal to a into r to the power of n minus 1. An represent nth term, n represent number of terms, r represent common ratio of the geometric progression, and a represents first term of the geometric progression. That is about the nth term of a geometric progression. So next, what is geometric series? Geometric series. Series concept we have explained in the beginning of this chapter. Geometric progression is there, means terms a, ar square and up to all those. If you write sum of all those, that will be the geometric series. In the same way, arithmetic series also. If a, ar square, so on up to a into r to the power of n minus 1 is a geometric progression, then the expression a plus ar square plus ar cube plus so on up to a into r to the power of n minus 1 is called as geometric series. This is about the geometric progression concept, definition, nth term of a GP, and also geometric series. Okay. Now we will go to the next concept, that is sum of first n terms of geometric progression. Sum of first n terms of a GP. That is Sn formula we are going to derive now. In the arithmetic progression, we did the same thing. Sum of first n terms of arithmetic progression. What is that? We have derived the formula. Alla formula derive madidivri. Sn is equal to n by 2 into 2a plus n minus 1 into d. In the same way we are going to do here also. that is in geometric progression. Let a, ar, ar square, so on up to a into r to the power of n minus 1 is a geometric progression. This is geometric progression agirli. Then we have Sn is equal to, that is sum of first n terms is equal to a plus ar plus ar square plus so on a into r to the power of n minus 1. This is Sn. Here let me take this as equation 1, and here I will consider 3 cases totally. What is that? First case, second case and third case. Those are all depends on the value of r. Depending on the value of common ratio, we will use different formulas here. What are those? Suppose case number 1 here, if r is equal to 1, if common ratio r is equal to 1, then what happens to the formula? Sn is equal to, means sum of n terms is equal to a plus a into 1 a into 1 square a, so on up to a only it is. How many a's are there? Here n times a is getting add. A n sorry add akonta untadri, means we will write here Sn is equal to n into a. This is the simple formula for sum of first n terms of geometric progression. Now coming to the case number second. Case number second, what we'll do if r value is less than 1. Okay, otherwise let it be right here. If r is less than 1, what we do? Multiply r to the equation 1. R to equation 1. What happens to the equation 1? Equation 1 implies r into Sn is equal to r into a plus ar square plus so on up to a into r to the power of n minus 1. R into Sn is equal to, r will get multiplied with all these, so it becomes ar square a into r cube so on up to a into r to the power of n minus 1 plus 1. This becomes a into r raised to n. Let me take this as equation 2. Okay, we will take here the operation taking equation 1 minus equation 2. This is Sn is equal to a plus ar square so on up to a into r to the power of n minus 1. Now second one, r into Sn is equal to, I am subtracting that. This is ar plus ar square plus ar cube plus so on. Last term will be a into r to the power of n. Okay, we are subtracting, change the sign here. ar square, ar cube, a into r to the power of n minus 1 and a into r to the power of n minus 1 will get cancels out. And now remaining left hand side Sn minus r into Sn, and right hand side here a remains in the first term, and in the second term this last term means minus a into r to the power of n remains. This has multiplied with minus sign now. Okay, means we have changed the sign there. What is common in the left hand side? Sn is common. Sn into 1 minus r is equal to, here a is common, a into 1 minus r to the power of n. We have Sn is equal to, sum of n terms is equal to a into 1 minus r to the power of n divided by 1 minus r. This formula we should use only when r value is less than 1. Common ratio value is less than 1. Then we should use this formula. Thank you. Case number 3, that is when r value is greater than 1, we will consider in the next session. Thank you.